A signal reached Earth that should never have arrived. It appears to come from beyond the observable universe, from a region that no light, no particle, no information should ever cross. According to everything modern physics tells us, this is not just unlikely. It is impossible, yet the data exists. Astronomers detected a strange burst. It did not match any known cosmic pattern. Its origin could not be traced to any galaxy we can see. It behaved in ways that break the rules that have governed science for decades. The deeper scientists looked, the more unsettling the conclusion became. This signal does not belong here. This is not just another space mystery. This challenges the very boundary of reality itself. In this video, you will understand what the observable universe really is, why it has a hard limit, and why nothing from beyond it should ever reach us. You will learn what scientists actually detected, why it shocked the physics community, and how it connects to some of the deepest theories about space, time, and existence. By the end, you will see why some physicists believe this could force us to rethink the structure of the universe itself, because this is not just about a signal. This is about the possibility that our understanding of reality is incomplete. To understand why this is so disturbing, you first need to understand a simple but powerful idea: the observable universe. The universe is vast beyond comprehension. It contains hundreds of billions of galaxies. Each galaxy holds billions of stars around. Many of those stars are planets. But despite this unimaginable scale, there is a limit to what we can actually see. This limit is not because our telescopes are weak. It is not because we have not looked far enough. It is built into the structure of the universe itself. Light does not travel instantly. It has a speed limit, about 300,000 kilometers per second. That sounds fast, but across cosmic distances, it becomes a restriction. When you look into space, you are looking into the past. The light from distant galaxies has taken millions or even billions of years to reach you. Now, here is the key detail that most people never think about. The universe itself is expanding, not just moving outward into empty space. Space itself is stretching. This expansion began with the Big Bang and has continued ever since. Over time, distant regions of the universe have been pushed so far away that their light will never reach us. Not now, not ever. This creates a boundary, a cosmic horizon. Everything inside this horizon is the observable universe. Everything beyond it is completely hidden. It is not just invisible, it is unreachable in principle. No signal from beyond that boundary should ever cross into our region. This is not speculation. This is one of the most well-tested ideas in cosmology. It is supported by observations of the cosmic microwave background, the oldest light in the universe, which acts like a snapshot of the early cosmos. It confirms that there is a limit to what we can access. Beyond that limit, there may be more galaxies, more stars, entire regions of space that we will never see, or something even stranger. This is where the mystery begins, because despite this clear boundary, scientists have detected signals that do not behave as expected. Signals that challenge the assumption that the universe is closed off beyond a certain distance. And one of these signals stands out. It appears to come from a region that should be completely disconnected from us. That alone should not be possible. At this point, it becomes important to bring in one of the leading voices in modern physics, Brian Greene. He has spent decades studying the deepest questions about space and time. He has explored ideas that go beyond everyday intuition, concepts like extra dimension string theory, and the possibility that our universe is just one part of a much larger structure. According to his work, the limits of the observable universe may not be the limits of reality itself. There could be layers beyond what we can see, entire domains that exist outside our cosmic horizon, regions that follow the same laws of physics, or perhaps completely different ones. But here is the critical point. Even if those regions exist, they should not be able to interact with us. The boundary is absolute, or at least that is what we believe. Now consider the implication of a signal that seems to cross that boundary. Either the signal is being misunderstood, or the boundary is not as solid as we thought. Both possibilities are unsettling. If it is a mistake, it means our instruments or interpretations are flawed in ways we do not yet understand. If it is real, it means something far more profound. It could suggest that the universe is connected in ways that we have not yet discovered, that there are hidden pathways through space-time, or that our entire model of the cosmos is missing something fundamental. This is why scientists are not rushing to conclusions. They are questioning everything. They are rechecking the data, testing alternative explanations, looking for any known phenomenon that could produce such a signal. So far, nothing fully explains it. And that leaves us with a question that cuts to the core of modern science. Did something reach us from beyond the universe, or are we standing at the edge of a much larger reality that we are only beginning to glimpse? This is not just about space, this is about the limits of knowledge. Because if even one signal can cross that boundary, then the universe is not what we thought it was, and that changes everything. Welcome to the channel. If you are curious about the deepest mysteries of the universe and want to explore ideas that challenge reality itself, make sure you subscribe. The universe feels endless. But it is not endless in the way most people think. There is a limit, a real physical boundary, not a wall you can touch, but a boundary written into the laws of nature. Scientists call it the observable universe. This is everything we can ever see. Every galaxy, every star, every signal that has had enough time to reach us since the beginning of time, it stretches about 93 billion light years across. That number sounds impossible, but even that is only a portion of what actually exists. The rest is hidden. The reason for this limit is simple, but also deeply unsettling. Light has a speed. It cannot move faster than that speed, not through space, not through time. This speed acts like a cosmic speed limit. It controls how information moves across the universe. Now combine that with something even stranger. The universe is expanding, not like an explosion moving outward into empty space. Space itself is stretching. Every second, the distance between galaxies increases. The farther away something is, the faster it moves away from us. At extreme distances, galaxies are being pushed away faster than light can travel. That means their light will never reach us. Not in a million years, not in a trillion years, never. This creates a boundary, a horizon. It is called the cosmic horizon. Anything beyond this horizon is cut off from us forever. No signal from that region can cross into our part of the universe. It is not just difficult, it is physically impossible under the laws we know. This is W. Here the story becomes even more precise. There is a specific signal that marks the edge of what we can see. It is called the cosmic microwave background. This is the oldest light in the universe. It comes from a time about 380,000 years after the Big Bang. Before that moment, the universe was too dense and too hot for light to travel freely. Everything was trapped in a glowing fog of particles. Then something changed. The universe cooled just enough for light to break free. That light has been traveling ever since. It fills the entire sky. It surrounds us in every direction. It is not visible to the human eye, but sensitive instruments can detect it as a faint microwave glow. This is the furthest back we can see. Beyond this point, there is no light, no images, no direct information, only darkness. And behind that darkness lies the unknown. There could be more galaxies beyond the horizon, entire structures larger than anything we have observed, or regions that look completely different from our own. But none of that should matter to us, because none of it should ever affect us. The laws of physics draw a clear line, a strict separation between what is inside our observable universe and what lies beyond it. Nothing crosses that line, no signal, no particle, no message. This is not a theory that scientists debate casually. It is a foundation of modern cosmology. It shapes how we understand space, time, and the origin of everything. So when a signal appears that seems to ignore this boundary, it does not just raise questions. It breaks the rules, because for that to happen, something must have traveled from a region that is completely disconnected from us, and that should not be possible. The signal did not arrive with a warning. It appeared as a brief spike in data, a burst of energy that lasted only a fraction of a second, easy to miss, easy to dismiss as noise, but it was not noise. Astronomers noticed something unusual right away. The signal was too clean, too structured. It carried a pattern that did not match the random chaos of space. Most cosmic signals fade slowly or repeat in predictable ways. This one behaved differently. It came fast. It peaked sharply. Then it vanished. At first, scientists compared it to known phenomena. One of the closest matches was something called fast radio bursts. These are powerful flashes of radio waves that come from distant galaxies. They release more energy in a split second than the sun produces in days. Some repeat, others appear once and never return. For years, they were one of the biggest mysteries in astronomy. But the signal did not fully match them. Fast radio bursts have signatures. Their energy spreads in a way that reveals how far they have traveled through space. As they pass through gas and plasma, their frequencies stretch and plasma. Their frequencies stretch and scatter. Scientists can read this distortion like a fingerprint. It tells them where the signal has been. This signal carried distortion too. But something was off. The numbers did not line up with any known path through the universe. It looked as if the signal had traveled through regions of space that do not exist on our maps. Regions with different properties, different densities, possibly even different physical conditions. That alone raised concern. Then came the energy profile. The burst was extremely powerful, but not in the way expected. It did not decay like a typical astrophysical event. It held its intensity longer than it should, almost as if it had not lost energy over distance in the normal way. That is not how signals behave across billions of light years. There was also no clear source. Astronomers pointed their instruments toward the origin point. They searched for a galaxy, a star, any object that could explain. Ain't it? There was nothing. No visible structure, no known emitter, just empty space. That empty space is where the real problem begins. Because according to current models of the universe, there should still be something there. Even the darkest regions contain faint galaxies or background radiation. Total emptiness at that scale is rare. Yet the signal pointed to a region that seemed almost disconnected. Some scientists proposed a simpler explanation. An unknown object within our universe, a new type of neutron star, a rare black hole event, something exotic but still within the rules, but the data resisted that idea. The signal did not behave like it came from inside the observable universe. Its properties suggested a journey that does not match the structure of space we understand. And then came the most unsettling interpretation. If the signal did not originate from any known region within our cosmic map, then its origin might lie beyond it, beyond the observable universe. That suggests was not made lightly. It challenges decades of established physics. It questions the idea that our observable region is completely isolated. It hints at the possibility that something crossed a boundary that should never be crossed. And if that is true, then the signal is not just unusual. It is evidence of something that should not exist. There is a rule that everything in the universe must obey. Nothing travels faster than light. This is not just a guideline. It is a limit built into the fabric of reality. It comes from the structure of space and time itself. Every signal, every particle, every piece of information is bound by the speed. When something moves through space, it carries energy. The faster it goes, the more energy it needs. As it approaches the speed of light, the required energy rises toward infinity. That is why no object with mass can reach or exceed that speed. This rule protects causality. It keeps cause and effect in order. It ensures that information flows in a consistent direction across the universe. Now combine this with something even more extreme. The early universe went through a phase called cosmic inflation. This happened in the tiny fraction of a second after the Big Bang. During this period, space expanded faster than the speed of light. Not objects moving through space, but space itself stretching at an incredible rate. In that brief moment, regions that were once close together were pushed unimaginably far apart, far enough that they became permanently separated. After inflation ended, the universe continued to expand, but at a slower rate. Still, the damage was done. Vast regions of space were now beyond each other's reach. Light from those regions would never have enough time to cross the growing distance. They became isolated, cut off. This is why the cosmic horizon exists. It is not just about distance, it is about time and expansion working together to create separation. Even today, this expansion continues. Galaxies far away are receding from us. The farther they are, the faster they move away. The faster they move away, at a certain distance, their recession speed exceeds the speed of light. This does not break the rules because space itself is expanding, but it creates a barrier. Light emitted from those regions can never catch up. It is like trying to swim toward a shore that is moving away faster than you can swim. No matter how long you try, you never get closer. This is the reality of our universe. Entire regions are slipping beyond reach every second, and once they cross that boundary, they are gone forever from our perspective. This is why the signal is so disturbing. For it to reach us, it must have carried information across a distance that should be impossible to cross. It must have escaped a region that is COSA. When disconnected from us, that violates the structure of space-time as we understand it. It suggests one of two things. Either the signal traveled faster than light, which breaks one of the most tested principles in physics, or it found another path, a path that bypasses the normal rules of distance and expansion. Both possibilities are dangerous to our current understanding, because if information can travel in ways we do not understand, then the universe is not as closed and predictable as we believed. It means there could be channels through which data flows across forbidden boundaries. Information that should remain hidden could leak into our observable region. Scientists sometimes refer to this idea in a quiet, cautious way. Forbidden information. Data from regions of space that should never communicate with us. If even a single piece of such information reaches Earth, it means the barrier is not absolute. And if the barrier is not absolute, then the universe is connected in ways that current physics does not describe. This is where the tension deepens. Because once one rule begins to bend, others may follow. Scientists did not accept the signal as something extraordinary right away. The first instinct was caution. Space is full of strange events. Many signals that looked mysterious at first later turn out to have simple explanations. Instrument errors, interference from Earth, known cosmic objects behaving in unusual ways. So they started with the most conservative idea. Maybe this signal came from a source inside our own universe. There are extreme objects out there, neutron stars that spin hundreds of times per second. Black holes that tear apart entire stars, magnetars that release bursts of energy strong enough to affect space itself. Any of these could, in theory, produce something unusual. But the deeper the data was analyzed, the harder it became to fit. The signal into these categories, the pattern did not match, the energy curve was off, the path it seemed to travel did not align with known structures in space. So scientists moved to more exotic possibilities. One idea comes from the strange world of quantum physics. One idea comes from the strange world of quantum physics. It is called quantum entanglement. At the quantum level, particles can become linked in a way that defies normal intuition. When one particle changes, the other responds instantly, even if they are separated by vast distances. This connection appears to happen faster than light. That sounds like a possible explanation, but there is a problem. Quantum entanglement does not allow information to travel in a usable way. It creates correlations, not messages. Scientists cannot use it to send signals across space. It cannot carry structured data like the signal that was detected. So while it sounds promising, it does not solve the mystery. Another idea reaches even further, the multiverse. Some theories suggest that our universe is just one of many. Each universe could have its own laws, its own structure, its own history. These universes might exist side by side, separated by dimensions we cannot see. In rare cases, there could be interactions between them, tiny leaks, brief contacts, disturbances that cross from one universe into another. If that is true, then the signal might not come from beyond space as we know it, but from beyond our universe entirely. This idea is powerful, but it is also highly speculative. There is no direct evidence that such interactions happen. Then there are wormholes. These are theoretical shortcuts through space-time. Instead of traveling across vast distances, something could pass through a tunnel that connects two distant points. In theory, this could allow information to bypass the normal limits of space. A signal entering one end could exit somewhere else instantly. That could explain how something crossed a forbidden boundary, but wormholes, if they exist, are unstable. They would collapse quickly unless supported by forms of matter that have never been observed. There is no confirmed evidence that they can carry real signals. Another idea is even more unsettling. The simulation hypothesis. This suggests that reality is not fundamental, that everything we experience is part of a deeper system, like a simulation running on unknown rules. In such a system, unexpected signals could appear due to glitches, hidden processes, or external inputs. The signal would not be traveling through space in the normal sense. It would be appearing within the system from outside its visible rules. This idea is difficult to test. It sits at the edge of science and philosophy, and yet it cannot be completely dismissed. Each explanation reaches into deeper layers of physics. Each one tries to stretch the rules just enough to make sense of the signal, but none of them fully work. There is always a gap, a contradiction, a detail that refuses to fit, and that leaves scientists in a difficult position. Because when every known explanation fails, the mystery does not disappear. It grows. There's a possibility that scientists rarely say out loud. The universe might not be alone. Everything we observe sits inside a bubble of space and time. This bubble has rules, it has limits, it has a beginning we can trace and a structure we can measure. For a long time, this was enough. It felt complete, but modern physics has been pointing in a different direction. Some theories suggest that what we call the universe is only a small part of a much larger reality, a vast system where many universes exist at the same time, each one separate, each one expanding on its own. These are often called parallel universes. They may exist in higher dimensions that we cannot direct. We see dimensions beyond length, width, height, and time, hidden layers of reality that sit just outside our perception. This is not science fiction. It comes from serious attempts to unify the laws of physics. Theoretical models like string theory require extra dimensions to work. Not one or two, but several. These dimensions could be tightly curled up or extended in ways that are difficult to detect. Entire universes could exist within this higher dimensional space, like sheets floating in a larger structure. Brian Greene has explored these ideas in depth. He describes a reality where our universe could be one of many, each existing on its own layer, separated by dimensions we do not yet understand. In some models, these universes can come close to each other. Close enough to interact, these interactions would not look like normal events. They would not follow familiar patterns. They might appear as sudden bursts of energy, strange signals, distortions that do not match anything inside our universe. Something like the signal that was detected. There is also the idea of a higher dimensional space, sometimes called the bulk. In this view, our universe is like a surface embedded in a larger structure. Other universes could exist nearby in that same structure. If something moved through that higher space, it could, in theory, enter our universe at a specific point, not by traveling across normal space, but by crossing dimensions. That would bypass the cosmic horizon completely. It would not need to obey the distance limits inside our universe because it would not be moving through our universe in the usual way. This changes everything. It means the boundary we believed was absolute might only apply within our own layer of reality. Beyond that, there could be pathways that connect regions we thought were forever separated. It also means our universe might not be isolated. For decades, scientists treated the observable universe as a closed system. Everything that happens inside it is governed by internal laws. Nothing external interferes. But if a signal truly came from beyond, then that assumption breaks. It suggests that external influences are possible, that something outside our universe can reach in, even if rarely, even if only under extreme conditions. This idea is both exciting and deeply unsettling because it means the universe is not the full picture. It is only a part of something larger, and that larger structure may have its own rules, its own dynamics, its own unknown forces. For the first time, the signal begins to look less like an error and more like a clue. If the signal is real, then something much larger is at stake. It is not just about one strange burst of energy. It is about the foundation of physics itself. For decades, scientists have built a model of the universe that explains almost everything we observe. From the motion of galaxies to the behavior of particles, the equations work with incredible precision. Predictions match reality again and again, but this model depends on a few core assumptions. One of them is that the observable universe is a closed system, that everything we can detect comes from within it, that no information crosses the cosmic boundary. If that assumption fails, then the model is incomplete. Not slightly wrong, fundamentally incomplete. This has happened before in science. There was a time when classical physics seemed perfect. Then quantum mechanics revealed a deeper layer. Later, relativity reshaped our understanding of space and time. Each time, reality turned out to be more complex than expected. This could be another moment like that, because if a signal truly arrived from beyond the observable universe, then our definition of the universe itself is too small. The word universe means everything that exists. But in practice, scientists often use it to describe everything we can observe and measure. That difference matters. If there are regions beyond our reach that can still influence us, then the universe is not just what we see. It includes hidden domains, unseen dimensions, and structures that extend far beyond our current map. This forces a shift in perspective. The boundary we once treated as the edge of reality becomes just a limit of observation, and beyond it, something continues. There is also a deeper question about origin. The Big Bang is often described as the beginning of everything, the moment when space and time came into existence. But if there are regions outside our observable universe, or even outside our universe entirely, then the Big Bang might not be the true beginning. It could be a local event, one event in a much larger system. That idea changes how we think about existence itself. It raises questions about where the laws of physics come from, whether they are universal or only apply within our region, whether different parts of reality follow different rules. It also raises questions about structure. Is the universe smooth and uniform on the largest scales, or is it part of a complex network of interconnected regions? Are there hidden pathways that allow energy or information to move in ways we do not yet understand? The signal touches all of these questions at once. It acts like a crack in the surface of our understanding, a small opening that hints at something deeper beneath. And then there is the human side of this discovery. For the first time, there is a possibility that we have detected something that lies beyond the limits of our reality. Not just far away in space, but outside the very system we exist in. That is a different kind of discovery. It is not about distance, it is about boundaries. T suggests that reality is layered, that there are levels we have not yet reached, and that for a brief moment, something from one of those levels may have crossed into ours. This idea is difficult to accept. It challenges intuition, it challenges decades of research, but it also opens a door. Because if one signal can cross that boundary, then the universe is not silent beyond the horizon. And that means there is more to discover. A signal reached us that should never have existed. It crossed a boundary that defines everything we know about space and time, a boundary that was supposed to be absolute, and yet the data is there, quiet, precise, unexplained. Scientists are still searching for answers. It could be a rare event inside our universe that we do not fully understand yet. It could be a flaw in our measurements, or it could be something far more profound. Because if even one signal truly came from beyond the observable universe, then the rules are not complete. That means the universe is not closed, not isolated, not fully understood. It means there are parts of reality that exist beyond our reach, and somehow something from that hidden realm may have touched ours. This is where science becomes both powerful and uncertain. Every discovery pushes the boundary forward, but sometimes a discovery does something else. It shows that the boundary itself may not be where we thought it was. This signal sits exactly at that point. It does not give clear answers. It creates deeper questions. Questions about the origin of the universe, about the limits of physics, about whether reality extends far beyond what we can ever observe. And that changes how we see everything, because the universe may not be a single isolated system. It may be part of something larger, something layered, something still hidden, and for a brief moment, it may have revealed itself. If you found this idea fascinating, take a moment to like the video. It helps more people discover content like this. And subscribe to the channel if you want to explore more mysteries that challenge the limits of reality, because the next discovery might not just change what we know, it might change what is possible.